So I want to find the highest and lowest points on the intersection of the surface described by this equation and the plane whose equation is given by this. I don't know. What do you guys think that thing looks like?
Circle.
Say it again. Say it one time.
Round sort of circle.
Sort of circle. Actually, a cylinder that's not really circular, but kind of elongated, circular, or kind of contorted, and it's going along the z-axis. But when I got a plane slicing through, and so I think to answer the question, what's the intersection, amounts to nothing more than this. Taking a peek at the equation x to the fourth plus y to the fourth equals 1 in the xy coordinate plane, and just walk on that curve. Just keep walking, and look up at the corresponding plane, identify the largest and smallest z values. That being the case.
What? Did you want us to identify all the critical points? Because there's the two
I
side
intended,
values.
but I'll be honest with you, I don't remember how I phrased the question. Kind of
You asked for the highest and
You asked for the
lowest.
highest and
Highest and
lowest,
lowest,
but just
yeah.
knowing you.
Well, you only get the highest and lowest in this situation.
There's nothing wrong with that. But it's
You know, when I asked for the highest and lowest points, that means I really didn't want the orders.
okay, of course.
Triplets.
Ooh.
But
Actually,
only the
no,
ones
no,
that give you the highest and
you
lowest,
put
because you get
at
plus and
values,
minuses.
so you did have
But you only want the highest and lowest. You don't care about the in-between numbers, right?
Correct.
Oh,
I know, but I only know the word.
So you guys, I think the question amounts to this. If I can write so you can read it. I think if I were to isolate z in this equation, isn't this really my function f in two variables?
Why did you leave the plus in there next to the 2?
Say one more time.
Why do you have the plus in there next to the 2?
Because I wrote a minus in there and I made a mistake.
Oh,
I
okay.
was just fixing up. And if I set everything over here equal to 0, then I suppose that's the output of my function g. And the technique I'm going to use is, well, instead of using Lagrange, can we just use that other technique where I was trying to find absolute max, absolute mins?
No,
Why not?
because you're looking for the intersection, and so you can only do Lagrange.
Yeah, I think he's right and I'm wrong. Technically speaking, I can't use that absolute extrema technique because that's finding absolute extrema is a closed bounded region. And here, I'm trying to maximize or optimize over some curve living in the xy coordinate plane. So I think here, my arm's being twisted, I really do want to use the Lagrange multiplier technique. Let's do it. I think equating partials equal to each other times lambda, I can't see anything. Does that give me 2 being equal to, you guys finish the rest, 2 is equal to, I said, you guys finish the rest, 2 is equal to
4 lambda.
my 4x cubed times.
Lambda.
And I think my positive 1 is equal to, and then I've got the constraint relationship, that 2x plus y minus, excuse me, my goodness, I meant to say, I've got that constraint relationship, namely this equation here. Okay, so I confess, I come to class, I do not give you guys a single technique by which you can solve the system of 3 equations and 3 unknowns because they're nonlinear. But at a glance, I have to confess, in this example, it's not bad. I'll simply, I think I'll solve for lambda. Yeah. What, actually, is it lambda or solve for?
Or solve for x and y in terms of
Nice, because I think with these 2 equations, x can be expressed this way. Is that the cubed root of 1 over 2 lambda?
I think you're doing too much work.
What was that?
So,
I think you're doing too much work. I think you should divide the first equation by 2.
Yeah, I agree.
so just a question here. Do you want us to state why we can divide by lambda when we do?
What do you mean?
Well, because there could be a certain situation where lambda could equal 0, or x or y could equal 0. But I found, doing the homework, there have been a couple points where you'd have to divide by one of those, and so you have to make sure that it can't equal 0 before you do it. And so in this case, if lambda equaled 0, then you'd have 0 equals 1, which doesn't make sense. So, of course, lambda can't equal 0.
I just think...
Or is it just implied?
With the whole theory,
Yeah.
if it really is the case that the gradient for f is equal to some constant multiple of the gradient for G.
Okay,
For these two vectors to be parallel to each other, I couldn't have a zero vector anyways.
okay.
I think that would apply the partial for F, the gradient vector for F, at any value of X and Y is gonna be zero.
Okay.
And since I certainly would not consider such a gradient vector, I wouldn't care.
So you're just never gonna have a situation where, your variables could be equal to zero in
Well,
this
it's understood
situation?
that lambda's gonna be non-zero.
Okay. But not just lambda, I mean, there are other, problems where you could just divide by an X or something like that and state that
Now,
X is not
that
equal to
worries
zero.
me,
Yeah,
because in an equation, I really don't wanna divide both sides of an equation by something that's potentially zero.
yeah.
It means that you might lose some equations.
Yeah, so I'd go through and I'd look and I'd make sure that X cannot be equal to zero.
Right.
Yeah, okay.
I agree. You guys, can we finish? This implies that y is equal to the cube root of 1 over 4 lambda. So substituting into that constraint relationship, I suppose it tells me that 1 over 2 lambda, is that going to be to the 4/3? Plus 1 over 4 lambda to the 4/3 is equal to 1. What's next?
I'm doing way too much work.
I know. I'm just trying to do 5/4 stuff. Oh, really? The natural law.
Just solve for lambda.
How?
Combine the two terms, I guess simplify them and then combine them and math D it.
What would the math step be next?
Well, I would simplify each of those terms so that they have the same denominators, so you could add the fractions together.
Sorry, I'm being too sloppy.
A little bit.
My apologies.
But you
Oh,
don't.
wait, no, because, well, I would,
I only put the 4 lambda in there because you're the one who said, let's just apply our math techniques.
well, I would run, well, okay, so
We need to do on
4/3 of 1 is obviously just 1, right? So if we take 4/3 of
Oh, that's
4
fine.
times
Yeah, I
lambda,
can
and then,
write that way.
okay, and then we can simplify them, so that we get the same thing at the denominator, but you can't just add a 4 to the denominator where it's a 2,
This is math. I can
because,
do whatever I want.
but you're just making stuff up now, because,
Well, I'll make it legal. I wanted a 4 in there. I put
Yeah,
a
you have-
4 in
you have
there.
to justify
I'll compensate by
it, yeah.
multiplying the outside by
2 to the 4/3,
4/3.
yes,
Whoops, excuse me. Looks good.
okay.
So now I think we just got 2 to the 4/3 over 4 lambda to the 4/3 plus my 1 over 4 lambda to the 4/3 again. Now that I got a common denominator, I combine those two terms.
Yep.
Why can't you just distribute it?
Absolutely, distributing is fine as well. Again, if I'm not being too sloppy.
And then you can
See,
just,
when I use natural logs, I instinctively take log of both sides of an equation whenever I've got a flashing light going off, meaning I've got the variable up at the exponential position. So I'll take it back. If you want to use natural logs, you can do that. I just don't think it's necessary. Happy?
almost,
What do you mean almost?
well, you still gotta solve for lambda.
A piece of cake though, right?
Yeah.
So I guess that means 4 lambda to the 4/3. Ay, is that going to be cheapers?
4 lambda in parentheses to the 4/3.
I'm sorry to slow you guys. Is that 2 to the 4/3 plus 1?
Yep.
Or lambda is equal to...
Um,
1/4 times 2 to the 4/3 plus 1.
Raised to the 3/4.
Very nice. Yeah, you don't like it? It's ugly.
Yeah.
I think it's beautiful. By the way, does that answer the question?
No.
Oh shoot, I just ran them up, you guys. I solved for lambda. I really want the highest and lowest points, so what am I going to do with lambda value?
Just plug it back in, solve for your y's, and solve for your
Okay,
x's.
Plug it here and
Yep.
here, you're in business. But of course, there are shortcuts. Oh, as usual.
Hard time visualizing what's going on graphically, like,
You know, graphically speaking, here's what's really going on, even though it's different than the way I stated the question in English. It's as if I've got the xy coordinate plane here. And I've got some shape that's not really a circle, but it's sort of like a elongated one. And there's the graph of this equation in the xy coordinate plane. Now, I admit, my function f is going to be described geometrically speaking by the plane. Now, I'm not going to be careful in graphing the plane, but it's a plane that does something like this. And I maintain what I'm really trying to do is take a walk on this curve back in the xy coordinate plane, continue all the way around it, and identify what the large and small values are on this plane. I'm trying to optimize the z values.
Okay, so what does lambda look like graphically? Like,
It looks like a lot. What it looks like is very important, because I think technically speaking, when it comes to the gradient of my function g and the gradient of my function I labeled f, I think where these two functions, sorry, I'm not speaking very well. Can I take that back? I think where this function is maximized or minimized relative to that constraint over there is going to be where this level curve, or reflection level curves, has the following quality. That at that local max point, my gradient vector for that level curve for my function f is actually going in the same direction as a gradient vector for the curve in the xy coordinate plane described by this equation. That's why Lagrange multiplier works the way it does, is because at that point of intersection between my constraint equation x and y and one of the level curves from f are matched and touched in such a way that the gradient vectors are parallel to each other.
yeah, but they're not touching. They're not like on top of. They're not like, you know.
Well, that's true, because that red curve actually is down the xy coordinate plane. Although you got to confess, the way I phrased the quiz, I phrased it differently. I said, well, now let's consider the cylinder described by this equation. It's going all the way up. Let's talk about the intersection with the plane, and let's find the largest and lowest points where those two curves, or those two surfaces, I should say, intersect. But I think it amounts to the same darn question that I asked with Lagrange multipliers. I'm just trying to make it more interesting.
So, this just has to do with the shape. In x to the fourth plus y to the fourth equals 1, it kind of looks like a continuous flips box, or...
Looks like a what?
And I've never had the munchies before. A flips box is, they're like chocolate-covered pretzels. Oh my god, you've never... Those are from heaven.
What? Never heard of it. Sorry. I live in a...
Yeah, you were born in like the 70s, right?
Thank you, that was very polite. 60s.
Okay, 60s, okay. So, basically, it looks just like what the drawing that you just made, except it's only like this tall. And when you have the munchies, they're really good, so that was my point. You've either never seen them, or
I'm sorry.
really
It sounds good.
Well, it looks like a circle.
No.
Or sort of like a circle.
Yeah, can I do a better job? If here's the x-axis, here's the y-axis. I think it looks more like this. Bit of curvature to it, not quite a circle.
Okay.
I just did a poor job in black because my xy plane was a little different.
Not quite a box. Not quite a square, but not quite a circle.
Yes.
That's what it is.
Do you guys do my jobs? Sorry.
So, you take lambda, you plug it back into those two, and then spit you out a max value. Because when you do the cube root of that thing,
So when you substitute back in for lambda.
Well, it was back when you solved for lambda, you have a plus or minus.
Yeah, you know what? There is that issue. Because technically speaking, from here to here, didn't I really raise both sides to 3/4 power? Forget about the 3. If I'm raising each side to 1/4 power, doesn't that really mean I'm taking the 4th root of both sides?
Yep.
So technically speaking, I've got two values of lambda to check.
okay.
And you know, with this technique, the Lagrange multiplier technique, doesn't really tell you for free whether or not it's max or min. You're just going to have to dive in there and see which one's going to be larger, which one's smaller.
Do you...
Everybody.
That's kind of a dumb question.
There's never done.
It was really just like, can we just logic our way through and figure out which one's going to be the max and the min? But then I figured, no, Gallagher doesn't want that.
You made me sound like such a pain. You guys, is that okay?
So how do
Perfect.
you know that you have 4 max and min values unless you actually go through it, like, just by looking at it?
Well,
What's
to
kind of
maximize
unreachable?
Z, your X's and Y's need to be positive.
it's just, it's.
Well, yeah, if you take a peek at the picture here, I have an ink board. I got a plane. It certainly is the case that I'm gonna max out in the middle somewhere. It really is gonna have a maximum Z value, the curve Z, the plane Z, and it's also gonna have a min Z value.
It's
I
only
think
2
for
of
free
them.
from the picture.
It's only 2 of them,
To what?
max and min. Or 1 max and 1 min.
There's only gonna be one max Z value and one min Z value. I agree with that. You don't like that. Well-
Like before, like the other problem that, like the other, Lagrange multiplier problem gave us, there was like 8 different.
I remember that, but I think in that example, wasn't there actually looking at some kind of surface that was
Yeah,
like
it was-
constraint
it was a
equations, like an
lesson.
ellipsoid or something like that?
Yeah, that's right.
And I think at multiple points in the ellipsoid, like maybe 4 different points in the ellipsoid, I got the same corresponding Z value.
Yeah, but there's only gonna be like one, like, so you're looking for like absolute max, and it's like when you're on the ellipsoid, you're gonna be looking for like, there's only one absolute, right? One absolute max, one absolute min. In my
I
opinion,
agree,
roughly.
in both that example you're thinking of in class, as well as this one, there's only gonna be one absolute max Z value and one min Z value. Even with the example you just referred to the other day.
So why do we need to like write all 8 those things down?
Because I think I asked a question, determine all the points on the constrained surface for which I yield a max. I just phrased the question differently, just to be careful. Yeah, that makes sense.
Coming together.
Do you guys think we can do something different today?
Do we have a choice?
Well, I suppose you can mute me.
Can I maybe ask one homework question first?
Can I stop arguing first?
Okay.
So I really want to finish this discussion.
You have my red notebook?
You're gonna hit me, aren't you?
0 for 2. It's okay, Valerie, I forgive you.
Let me do this. Let me in the XY coordinate plane. I'm going to consider some rectangular region. I'll call it big R. And I'm going to create what you guys had so much fun with the last few semesters, a regular partition of this rectangular region, the XY coordinate plane, in such a way that I've got an arbitrary square sectioned off here in the middle. And if there's a corresponding surface, I don't care what it looks like. Then I think I can approximate the volume underneath the surface that's above that rectangular region that I labeled R, using what I refer to as a double integral. And what I'm going to do is take a peek at the sum. The values on this particular surface, can I give it a name? Can I call the surface the graph equation Z equals f of 2 variables?
I have a quick question.
Yes, please.
So those tangent planes that we learned about, so like, it kind of looks like, you know, it kind of looks like a derivative thing. So like, are we gonna do like derivatives using tangent planes? I don't know, it's just a weird question that I was thinking
I
about.
think when it comes to the notion of having a tangent plane, I think it mimics very well what you can back in Math 30 when it came to equations of tangent lines.
Yeah, so can,
Just your higher dimensional equivalent to that.
so like, instead of doing like partial derivatives and all that fun stuff, why can't we just do like, I don't know, like rate of change of the.
But see, I think what the partial derivative really represents, because when I look at the group of symbols right here, the partial of f with respect to say x, to me that represents the slope of a tangent line to that surface at a certain point, if I'm looking parallel to the x-axis. To me, that's very hard what it represents.
Okay.
Now, I suppose I can take some time sometime this semester and talk about a different way of coming up with the equation plan. I will, because I get to use a different kind of parameterization, which are the two parameters SMT, and I'll be doing just that. Just like how a line in 3 space can be described with 1 parameter, a plane can be described with 2 parameters. But you guys come back over here. Would you not agree that if I took an arbitrary point in this small rectangular region, call it, how about u sub I comma v sub I? Wouldn't this be the corresponding distance from that point up to the surface? And I think if I were to multiply the z value by, I don't know, small change in the area, in other words, the area that's square down here, is simply going to give me the volume underneath the surface. And now if I add all of those together, summing up the values of my FC value u sub I comma v sub I, and multiplying by the area of what you see down below. And if I take a peek at the limit, as n increased up bound, I think I'm going to get the evaluation of a definite integral. It's just that since I'm integrating over 2 space, I'm going to refer to that as a double integral. The notation I will use is the following. This will be rewritten as a double integral over some rectangular region R of my function f, evaluated x and y, and I'm going to integrate respecting area. Now I got to confess, in my picture, if these extreme values of x are a and b, and the corresponding extreme values for y are, how about c and d? I could rewrite this double integral using bounds of integration. I think that will simply give me the integral of my function f evaluated x and y. I'll integrate respect to x, and I'll integrate respect to y. My x values range from a to b, and my y values range from, where did I make up as letters? C to b. Thank you, C to b. Oh, by the way, as long as my function f is continuous over that rectangular region R, I don't think the order of the integration is important whatsoever. So I think I can just as easily integrate from a to b. And then from c to d, my function f, I'm just reversing the order of integration. But again, I can only reverse the order of integration if the function f is continuous over that rectangular region I labeled R. Oh, by the way, that's so important. Can I give it a name? If I got such continuity, then interchanging is what I sometimes refer to as Fubini's. You know what? Fubini's theorem. Don't blame me for that name.
Okay, so the interchangeability is Fubini's theorem?
Yes, it is. Fubini's theorem says if f is continuous, order of integration is not important. Well, you guys, let's put this to practice. How many of you are going to make it to Friday's math contest? Oh, that few of us. Wow.
What is it?
The math
Extra
contest?
credit or something? What's it for that?
Oh, yeah. I'll give you points for
Like,
putting it on.
is it worthwhile or?
Yeah.
You said 10, right? If you put it on a
Yeah, he said 10.
put it on a second.
Well, what do you define as an honest effort? I mean,
Don't leave.
well,
Just
yeah.
take one.
Okay.
So if we
We
get
didn't have to get.
negative points, is that okay?
Yeah, I suppose it's okay.
Okay.
I want you to really try.
My question is, you said if 10 is the minimum for an honest effort, how exactly do we get more than 10 points of extra credit?
If you score more than 10 points on the contest.
Does that commonly happen?
You gotta get more than 5.
No.
It happens.
It does.
How many questions are there?
So
I've taken it 3 times and my high score's been like 8.5.
I know.
Okay,
Awesome.
yeah, I can only hear one person at a time, so what'd you say?
20 questions, and they're 2 points each, you can get a max of 40.
Okay.
Oh, is that really true? I didn't know it was that high.
so
If you miss a question,
You lose.
you lose points.
And you hardly ever get a chance to answer all of them unless you're super speedy.
Okay,
You have to go through.
So if you answer the question correctly, I think it's 2 points. If you don't answer the question at all, it's 0 points. But if you answer the question incorrectly, it's a negative 1/2 point.
Yeah.
Yes.
so say we do really well, do we get more than 10 points in the
Yeah,
class?
that's what I'm saying. If you do well on the contest, you'll get those points.
So is that over 10?
Yes, sir. Every
We get
What kind
any
of
point
questions
after that?
are
All right.
asked?
Oh, you can see some examples online. You just go to the math website.
just go, you know where you check for your quizzes in the math department? And then you look and it says fun stuff,
Yeah,
I
look,
think.
fun stuff is click up top.
And
Click
one
that
of
on, you
oh,
can
on the
see-
tab, and it has sample questions.
Okay, are there like a lot of them?
There must be like
we
4 or 5.
It's like
Yeah.
IQ type test questions.
They're out of the box next questions.
They're not trick questions, but they're intuitive kind of questions. You don't need calculus to do this. Like Sierra College, as they said, it was only a Math B student who ever got the highest score here.
Typically, it's my pre-calculus level students that score highest on this
Yeah.
contest.
Is that because we're looking for like a fancy example and they're not? I mean, fancy reason?
You overthink.
Yeah.
Because your level of understanding of mathematics is so high.
So, like, let's say we only get like a point because
That
we
happens.
did.
Oh, trust me, there'll be plenty of negative scores.
So is that going to be, so is that gonna be like one?
Well, if you score negative, that means you give points to me.
Do we still get our 10, like, do we get 10 points regardless, or?
Yeah, I'm being a little goofy, because I think nowadays, in the past couple of years, there are new rules to the contest, that you can't leave the room anyways. What is them?
Chuck said that if you have a degree, you have to like write that you have a degree or something. Does that include an associate's degree? Or what if you've applied for an associate's degree, but you don't have it yet? Does that?
Shoot, you know what, that's a good question, I do remember something about that.
What it is if you already have a degree, your score count towards Sierra College average score in a
Right.
competition with all the other community colleges. That's all that means.
Right, you can still take the contest.
Yes.
We just won't be able to use your score.
So what do
Is
you
that
think?
just for a math degree or is that for any
Any
degree?
Yeah.
Any degree?
Like I put down that I don't
Like that doesn't
degree,
belong
so
yet?
my
Does that
score
count if
does
you don't
not
have
count
one?
towards Sierra
Correct, I mean,
College's.
that counts.
Okay.
Okay, so you have to have one then.
Like, if you get a good enough score, they'll look into you and make sure, and they, like, you don't, I wouldn't worry about putting
Yeah.
it down.
That's only,
Well,
that's a
and-
real, that's just for, because Sierra College is competing against every other community college in the United States. So if you already have a degree, your score can't be counted towards the school score, that's all that means.
And they have a
You would
point
go
where
on the
they,
test,
What's that?
because then you would go on the test, yes.
Right, yeah. You still have to be an undergraduate, basically.
We got a 3-1 our master's still. Jesus. Yeah, we got a 3-1.
So everybody, your first double integral to investigate. Now, I'm writing somewhat abstractly with the PA business. I'm integrating with respect to area, but technically speaking, once I put my bounds of integration in, then I'm just simply integrating with respect to one variable at a time. And I think in this particular example, my integral becomes, is that from 1 to 2 and then 1 to 3?
XY or X cloud?
So that's our domain, which is our box that you were trying, right?
Yeah, you can think of that as a restriction.
Okay.
What's next?
What if it was like,
Ah, shoot, you guys, I meant to make a mistake, and I wrote it correctly. Darn it. So you're ready, right? Yes.
what if it was like, instead of less than or equal to, what if it was just less than? So then it would be like a dotted line on the box instead of like a closed.
You know, I certainly wouldn't interpret that as volume, because it's just be the interior of something. So I really want to consider the boundary points as well. I will not have strict inequalities.
So are we calculating a volume?
Yeah, you can literally interpret this evaluation right here. Everything above my brace could be interpreted as a volume underneath the surface, z equals this business, over that rectangular region I described with my letter R. Now, you don't have to interpret it as a volume, but that is one way to interpret it.
So this is like our partial derivatives where we treat one as a constant and then integrate and treat the
Absolutely. So now when I integrate with respect to y first, I'm going to treat x as a constant, and we'll disintegrate. We'll disintegrate it. We do that by... Ooh, guys. What's your technique?
You're gonna show us?
It's math 31.
Why would we do that? Wouldn't it just be
By parts. Good.
parts? By parts? Why would we do by parts?
Because that's how you do that. You can't do you can't take the integral of the natural log.
I thought that the integral of a natural log is x ln x plus x.
Well,
Oh, yeah, do you want?
That's fine.
if you memorize it, yeah.
Integrate by parts.
Oh, yeah, I know.
What did you
but
say it was?
Isn't it just x ln x plus x?
I couldn't hear you. X, L, and X
Plus x plus c is that
Plus C,
minus X?
Oh, x ln x minus x?
Yes.
plus C?
Well, it's on a,
Yeah.
Really? It's minus?
Yeah. I'll prove it to you.
Oh, no, no, I'll take your word for it.
Okay.
Don't wanna waste class time.
I don't know, you guys, tell me what you're writing. The integral from 1 to 2. We're going to actually evaluate this innermost integral first, 1 to 3, natural log of x, y. We're going to integrate respect to y, and then we'll integrate respect to x.
So, never mind, keep going.
so, do you want your u and v values?
Are you able to just give me the answer?
X ln x minus x.
Why would they lie? Oh, yeah. What?
I feel so alone again.
Yeah,
Oh, yeah,
y ln x, wouldn't it be equals to y ln x?
Is that okay?
No,
Well, you don't like it.
no, I want you to explain why.
Do you guys agree with this?
And then ln y counts as a constant, or no, ln x counts as a constant.
Yeah, I'm anti-differentiating constant with respect to, oh, look at that, with respect to the variable y. That's just going to give me y times a constant. Quick application of integration by parts in your head will allow you to take this, the integral of natural log of y and simply rewrite it this way.
This is getting kind of trippy too fast. So, like, it's like partial fraction decomposition.
Partial fraction decomposition doesn't apply because I'm not integrating a proper rational expression.
Yeah, I was thinking of partial fraction decomposition.
Everybody happy so far?
No,
Why not?
because you didn't finish your parenthesis.
Oh, sorry. Gee, clean up here.
I get the feeling that that is so far down on the
So next, when I integrate respect to x, I get
something really ugly.
how about a mistake?
Yeah.
Because I think my job next is going to be just evaluating the y values.
Can you repeat one more time the y ln x for a concept?
Would you not agree with this? Empty, no calculus. Can I first just split this up into sum two terms?
Okay.
Okay, look, if I'm going to now integrate respect to y, don't look at the second term. Integrating this term respect to y is sort of like integrating a constant. If this were a 5, wouldn't this antiderivative be 5y?
Okay.
And that's all I did. I was treating natural log of x as constant with the special mathematical glasses on, for which I was wearing when I was integrating respect to the variable y. Happy? And I maintain that I can evaluate, actually, I don't know what it evaluates to. From 1 to 2, cheapers, is that going to be a 3 natural log of x? Plus the natural log of 27 minus 3. Yes.
Do you ever do double improper integrals? Or not improper,
Indefinite?
not because, or I'm just mixing up my terminology. Basically, because these are, yeah, indefinite, yeah. Because these are definite intervals.
Absolutely. It's just the process is going to be the same. I just don't evaluate at the bounds of
Okay,
the
I was
equation.
just checking.
You guys, did I miss something? I forgot to subtract off my antiderivative value, lower bound of integration. Yikes. Help me with this. What's natural log of 1?
0?
I can't hear.
No,
Yeah, I think it's irrelevant.
yeah, but on the second one, you're gonna get an ln of 0, so.
True. I just want to make sure you understand that I really am plugging 1 in for y, not x. So I get a minus natural log of 1? Excuse me, minus natural log of x. Is that a plus 1? You guys just double check my report.
Why'd you put ln of 27? It seems a little. No, I understand you can do that, but it's just arbitrary. As opposed to just putting 3 ln 3, they mean the same thing.
Well, I certainly call it arbitrary, but I just thought mine looked pretty.
Okay.
I was just gonna ask if this were indefinite and you got a constant of integration in the inner part, would you end up having that constant times the other variable?
So that's something you would have to worry about if you want to talk about such kind of integration, which I'm not. But you guys, as long as my arithmetic is correct, anything I can combine real quick?
Your ln of x's.
Yeah, so I think I've got the integral from 1 to 2 of, can you help me with this? Is that the 2
4
natural log
ln
of
of,
x?
yeah, 2 ln of x.
Is that plus natural log of 27, then is that a minus 2?
Yep.
Oh shoot, now I can anti-differentiate with respect to x. And anti-differentiating with respect to x, oy oy oy. You guys, I'm doing all the work, you do some work.
Well,
Nah, we're good.
you got to do your integration by parts again in your head there.
2x,
So
ln x, yeah you do.
yeah.
Oh, you're killing me, minus 2x. Ay, ay, ay.
Plus x ln 27 times this.
And I'm gonna evaluate from 1 to 2. So I guess in the end, numerically speaking, I really, guys, I'm serious, I have no idea what I get. Is that a natural log of, I can't do it.
16?
This seems really, really messy.
It is? I guess that matters, is that a minus 4? Plus 2 natural log 27. Minus 4.
That one's not prettier?
What's that?
So that one's not prettier?
No, I didn't want to do the arithmetic in my head. I didn't know if you'd notice that. And is that a minus, is that a negative 2 plus 27? Or excuse me, I meant the natural log of 27. Then it might be. Do you guys mind if I stop? This is arithmetic.
What section is this?
I have no idea.
13.1.
Can you just call it 13.1 and 13.2? I personally just don't like to separate those two sections. To me, it's all the same.
Oh, of course. Our guy's totally gonna give us a trig function. Ain't that right?
Eventually.
Calling it right now. Call it on the test.
You guys, I'm sorry for my horrible pen. Oh, that's what's bothering me.
That was the cost of all my handwriting issues. Sorry, it's just
Ay, ay, ay.
pen and lighting.
So, question. If you and I don't actually have the function algebraically speaking in the integrand position, but we know something about it, for example, like the evaluation of its level curves, I think this might be enough information to approximate the evaluation of that integral. Because I think to approximate this double integral simply amounts to the following. Looking at volume,